B with your Monday lesson. I hope you guys had an excellent weekend. So this one will be another informational lesson. So just whenever you have a chance to go through this video, that would be great, or just to click through the PowerPoint. We're continuing with our forces and structures unit, and we're talking about failure and strength. So kind of a continuation of what we talked about last lesson. So we'll take you through the PowerPoint, and that'll be all that you have for today. So we talked about different types of failure with our four internal forces. So our compression failure, our torsion failure, our tension failure, and our shear failure. And we learned some different terms for those. So what I have here is a picture of a rock structure that's gone through a failure. As you can see that it's cracked and shifted. And so just what type of failure is happening in this photo? We've got some buckling, we've got some shearing, and we may even have some twisting in there. But there can be multiple types of failure on an object or on a structure, depending on the forces being put onto them, because eventually over time even the force of gravity will start to break down different structures, and that's why they eventually fail over a long period of time. But that's what we'll get into today, is a little bit of strength and a little bit of failure, as well as intentional failure, which we'll talk about in just a little bit. So the previous forces are all considered internal forces. So like we talked about on Friday, I believe, with the buckle, the shear, and the twisting failure, those are all different types of internal forces and internal failures. So now the question is, how do we stop these forces from causing structural failure? As we learned earlier in this unit, using certain shapes can help provide strength. So we didn't get a chance to touch on this before we left for the closure, but different shapes, you can see these U shapes, these triangular shapes, they all help to add strength to a structure. So depending on how we construct our different shapes, like we did with our columns and our beams and our panels, we're able to add strength to our materials and to our structures. So you can also add pieces to the materials of the object. This will strengthen the object at appropriate locations. So you can see this is a picture of a boat, and the ribbing or the pieces of wood placed in between and over top add strength. So the force of the water is not crushing the boat inward and is providing strength and stability to the overall boat. So as we continue on, we're going to talk a little bit about fatigue. So what does the word fatigue mean? We use it a lot when we're talking about exercise. When we're talking about exercise, like when we get tired, or we've done something for a long time and we're just out of breath, like the beep test or the 12-minute run, we get tired or we get fatigued. And basically what that means is just over time, the stimulus, in this case the running, has taken away our energy, and we've eventually just slowed down and are now walking. That's what fatigue is it's long-term exposure to a certain force that's caused us to get weaker or get tired. The same principle applies when we're talking about structures. So when we apply a force to a material, whether that's the force of gravity, us pushing it or twisting it or whatever, that causes the particles to move and shift around within that structure or within that item that we're applying the force to. When the particles are forced to move, like we're adding a force that is making the particles move, that they're not moving by their own choice, that causes the bonds between them to start to break apart and separate. When those bonds start to break apart and separate, the material and the structure itself starts to weaken as well. Eventually, over time, when we break enough of those bonds apart, the entire structure or the entire material breaks down and separates or gets crushed or breaks or whatever. But eventually there's not enough bonds to hold those particles or that material together, and it fails just due to the continuous pressure of an overall force. So an example of this is just when you're standing on a brick or on a can or anything like that. Over time, if you stand on an object long enough, or you apply the same force over and over again long enough, eventually that structure is going to break. If you've ever seen a mechanical pencil and the little piece here, over time you can add little bits of force and move this up and down, but eventually that up and down movement is going to cause this piece to snap, not because you've added any more force to what you're doing to it, but over time, that same repetitive force slowly breaking apart the bonds of those particles will cause that piece to snap. And that's what we see in the example of like a mechanical pencil, the little bendy part here. If I did this every day for a couple of weeks, eventually this is going to break and snap off, and I'm not going to have access to it anymore. I'm not going to do that today, but eventually that would happen. And then we're going to end off today by talking about failure and is it a good thing or a bad thing? So, is failure always a bad thing? In most cases, it is. We don't want things to fail, but sometimes they're built that way to provide safety for us. And a couple of examples that I have here are of a boat engine that you would see at the back of a little boat or even at the back of a bigger boat, but some sort of motor for a boat, as well as a car bumper. In this case, these objects, will start with the car and we'll move to the boat motor as well. But for a car, when you get into an accident, the bumper and even the fender are made in such a way that upon impact, they absorb most of the force and then disperse it over the entire bumper. But this causes the force to not go into you, but rather it spreads out throughout the bumper, and that's why the bumper breaks. That's why when there's damage done to the bumper or the fender, you usually have to replace the whole thing because they're designed to fail in such a way that they absorb the force of the impact from the accident, and then the bumper breaks down. So if your bumper is already cracked, it's actually not designed properly anymore to absorb that force. So you are going to feel more of the force. That's why if your parents have ever gotten into a car accident and their bumper is damaged, even if it's just a little bit, usually they have to end up replacing the whole thing because it's designed to absorb impact and then break. So if it's already slightly broken, it's no longer going to be able to absorb the same amount of force from the accident. The same thing with a boat motor, where the pin inside that's holding the propeller on is designed to break when too much resistance is being applied to the propeller itself. This is in the case of like if it's jammed up with seaweed, it's not going to continue going and gaining more seaweed. That pin will break or pull out when too much resistance is applied. It's also for if somebody were to swim beside a propeller and not realize it, that if it hits into something heavier, it will break and stop and prevent doing any other damage from the person maybe swimming by the boat. And so that's actually designed, the pin in this little propeller here is designed to break with minimal resistance applied to it so that it's not causing excess damage to the boat or the motor itself. And that is our lesson today, talking about failure and fatigue as well as how we can prevent some of these failures from happening. So make sure you guys check back Wednesday. I'll have another informational PowerPoint for you guys, and I hope you guys have a good rest of your week. Talk to you later.